Hello. So in this lecture of the capacitor filter, we will discuss some important questions or important aspects of the capacitor filter. And in this course, we are going to address the first question. This is how to get good filtering in a capacitor. What are the factors that lead to good filtering process? Means your ripples are minimized to the maximum extent. What you have to do, what you need to have. What are the parameters that you need to fix, that we will discuss here. So from the physics of filtering, physics of the capacitors, what we learned, that the time constant is the most fundamental factor in the filtering process in a capacitor filter. The time constant RC, it must be large enough so that in between the peaks, the capacitor is not discharged totally. I told you in the last lecture that if this is the process, if these are the two peaks, in between these peaks, the capacitor is discharging in this manner. It is a line that is going down slope, discharging capacitor. So in this process, during these two peaks, in this time interval between two peaks, the capacitor must not discharge totally. The capacitor must not discharge totally, completely. This should not happen, so it needs to have a large time constant. So for low values of load resistance, we need to have high capacitance. For low values of load resistance, to make T is equal to RC large, C should be large. So one method to do this, C should be large. So in this process, what is used in the practical situation, we use the electrolytic capacitors. So electrolytic capacitors, if you want to know more about electrolytic capacitors, you can tell me in the comment section. I will make a separate video. Electrolytic capacitors are used in filters. As electrolytic capacitors have large capacitance. Electrolytic capacitors have large capacitance. Their capacitance value is very high. So these capacitors are used. However, there are some problems that may arise due to large capacitance that we will discuss sometimes later. At this moment it is not required. The main effect is the heating effect, and there are methods to get rid of that heating effect. So we will move to our next question. And our next question is a very relevant question because this is many times asked in the university exam or in any interview process. As I told you, these questions are asked in the Viva examinations and in the recruitment process also. So here you have to show that the filtered DC output is greater than the unfiltered supply. How will you show this? So let us see how can we show this. So we have a full wave bridge rectifier here, and there is a capacitor filter. We consider two situations. When the switch is this one is the switch, this one is the switch. In one case the switch is open, means the capacitor is not working, and in the other case the capacitor is working when the switch is closed. So we will discuss two separate situations. When the switch is open, the output will be an unfiltered pulsated DC, and if you attach a meter here in the output, if you attach a meter to read the voltage, it will read the average value of the voltage, and the average value is obtained by multiplying the RMS value with 0.9. This is a concept which is explained in the chapter of alternating currents, And if you have still queries in this section, you can comment me in the section. This is the RMS value, root mean square value, AC supply, and we multiply it by 0.9 and we get 9 volts. So this is the switch open or unfiltered output. This is the unfiltered DC. Now in this situation, when the switch is closed, suppose I am closing the switch, the capacitor is in action, it is filtering the output. In that case, the output will be the peak value. Peak value is obtained by multiplying 1.414 to the RMS value, so it is 14.14 volts. So you can clearly see that the voltage output in the after filtering DC voltage is much larger than the unfiltered DC output. Now the next question that is also asked is how to find the voltage across RL, the load resistance. How will you find it? How will you calculate it? So you have to remember the important concept that in filters the capacitor charges to the peak value, so we do not use the multiplicative factors 0.9 or 0.45 that are used for AC. Okay, it is the capacitor peak voltage. That this is the concept you have to use. So if you are considering this half wave rectifier with a capacitor filter and you have a 120 volt AC supply and you have a transformer here which has ratio of turns is 10:1, then the peak value is, then the RMS will be 120 by 10 is equal to 12 volts and peak value will be 1.414 into 12, that is approximately 17 volts. If there is no filtering, then you can use this 0.45 because there is no capacitor. So there is no question of charging to peak value. You have to multiply this with the factor 0.45 that is used in the AC analysis and you get 5.4 volts. So you can clearly see the difference. Now one important concept is what is the effect of polarity of the capacitor in the capacitor filter circuit. Can you attach a capacitor filter as according to your choice, or is there a condition for its polarity? So I must tell you, this is a very important factor, but it is neglected many times in teaching during learning of this rectifier filtering circuits. You have to remember the fact that the filter capacitor charges to the peak value of the AC waveform. This is the most important thing. So filter capacitors are rated for this higher voltage and capacitor polarity is an important factor. Now let me show you a diagram. Again, it is a full wave rectifier that I showed in the last page. This is the diagram. Again, you have a 120 volt AC supply, 10:1 transformer. The fundamental thing you have to remember is capacitor filter. Capacitor filter works when the capacitor is charged to the peak value, of input AC. This is the fundamental thing. Now if we come to the polarity, you can see that the plus lead, the plus point is at the bottom. In most of the capacitor filters, they are electrolytic type. As I told you, for rectification, electrolytic capacitors are used. Now, if the polarity is such that the plus one is above or in the backward side, it can cause explosion. It can cause burning of the rectifier. So this polarity is very important if you are using the electrolytic capacitors. For electrolytic capacitor, the polarity is a very important factor. If the polarity is not proper, there can be explosion or burning, explosion or burning of the capacitor, burning of the electrolytic capacitor. Electrolytic capacitor. So this is all about your electrolytic capacitor, capacitor filter. The next type of filter that we are going to discuss is the inductor filter. Now what happens in an inductor filter? First let me tell you the physics, the basic thing. An inductor is also called, an inductor is also an inertia element, as it opposes any change in current, of the circuit or in the circuit, whatever you can say. Inductor stores energy in the form of electromagnetic field, and it is half Li square. So this is the inertia element, and this property is used in inductor filter circuits. Now what happens, as I told you in the previous lectures, filter circuits are used for removing the AC components or the change, something that is changing the ripple factor. So basically the inductor filter is this type of a circuit where you have a inductor. Now there is a term filter choke. Choke means to strangulate, to forcefully stop something, that is called choke. A choke is another name for an inductor, CHOKE. Why it is called? This is used in the power supply because it chokes off or it forcefully stops the ripples. Inductor is also called choke, which means to forcefully stop. If you are forcefully stopping someone's breathing, it is called choking. So this is a term used for forcefully stopping something, stopping the flow of something, that is called choke. This is used because it chokes off or stops the ripples. This term is used, you must have heard choke coils in tube lights that are used in our households, not are used, that were used once in our households. They contain chokes. Let me try to show you a figure if you have. So this is the reason it is called choke coil, because it forcefully stops the ripples or the AC components. Let me show you, find a proper diagram so that it can be shown to you. So choke is something like this. Difficulty in breathing. Someone is forcefully stopping the breathing process. What happens in breathing? It is similar to some AC or wave when your lungs are inflating and deflating periodically. It is stopping the periodic motion. It is called choke. So this is a term that is used in this process. So this term is used, this is choke. choking is used because it chokes off or stops the ripples. This is the reason it is used in the power supply or electrical engineering term. So it opposes current, any change in current. So this is used in series with the load resistance. So any change in load current is opposed by this inductor or the choke coil. The inductor is anything when a conductor is in a coil form. When a conductor is in a coil form, I will tell you in details regarding this. The inductor is connected in series with the load resistance, and it opposes any change in current through the load, current through RL. Any change is opposed. So this is the basic action of a choke coil or a inductor filter. This is how it opposes the change in current. And one most important thing, that choke coils are not very often used in 60 Hertz power supply. Initially they were used. That is why I told you in the beginning that choke coils were used in the tube lights many years ago. Let me give you an example. This one is the diagram of a tube light that was used long time back, typical diagram. Here you have a starter, you have a choke, and you have a AC input. So it was used many years back in the household circuits where the frequency is about 50 to 60 Hertz. Now solid state circuits are used and electrolytic capacitors are used. So ripples are more efficiently removed. In case of choke coils for household circuits, they used to be very large and heavy and expensive. So these have been removed by solid state filters. Initially, choke coils were used in tube lights in households, but they were heavy and expensive, so they have been removed. They have been removed, or you can better say replaced, by solid state devices. Solid state devices. So this is the basic mechanism of a choke coil. If I can find some other diagram, this is the most relevant diagram that you can see, that you can realize, or it will remind you of the choke coil that is used. This was the choke coil that was used initially for tube light circuits. Now they have been removed. So this is the basic principle of a choke coil. Now what happens here? Choke filter. The main physics, let me come to the main physics. When you have a choke or inductor, in case of an AC supply, one important thing that you have to understand regarding this, AC supply, with inductor and resistance. Inductor and resistance. The term used is called impedance. Impedance. And mathematically, impedance in this case is root under RS square plus XL square. Now this XL square is called inductive reactance. XL is inductive reactance. Inductive reactance. This is a quantity that measures the response or the resistance. For simplicity I am using this word, though it should not be used. Response or resistance of inductor to an AC supply. To an AC supply. This is the term which is used. And XL is omega L. Omega is the frequency of AC. So you can see frequency of AC. So this XL is large for large high frequencies. XL is high for high frequencies. It is opposite to capacitor. High frequencies. And XL is low for low frequencies. So XL will allow DC which has zero frequency, and XL will block, not XL, it should be L, inductor L. Inductor will block high frequencies, and this is the most important aspect of an inductor filter, that it blocks very high frequencies. Now in the next lecture we will see how to calculate the ripple factor and what is the main difference from the inductor filter from the capacitor filter. So stay connected, watch the videos. We will meet in the next lecture.